Hey everyone, we're going to take a look at number 7 in section 3.8 for the implicitly defined function, calculate the derivative with respect to x. And this is the equation they give you. So what do they mean here? Of course, they're talking about finding dy dx, right? Y is implicitly given as a function of x in this equation. Now, in this case, you could solve for y, could be done, and then find the derivative explicitly using the various derivative rules that we have, but we want it to do it as they have asked us to do it, and that is implicitly. Um, well, let me just say we're going to find it implicitly, I guess, using implicit differentiation. Um, so how do we do that? We simply take the derivative with respect to x of both sides of this equation. I'm going to let y prime be dy dx, so just to sake of simplifying the notation here. And so what do I do over here? I take the derivative of each one and add them together. And what's the derivative of y to the negative 3/7 with respect to x? So notice y is a function of x. Again, we could solve for y here explicitly, but we want to use the chain rule here, right? Because we're taking the derivative with respect to x of this. So the outer function is y to the negative 3/7, and that derivative will be negative 3/7 y to the subtracting 1 or 7/7 from negative 3/7 gives me negative 10/7. There's the derivative of the outer function times the derivative of the inner function. What's the derivative of the inner function with respect to x? Well, that's just dy dx. Instead of dy dx, again, I'll write y prime. So dy dx is here. So this is negative 3/7 y to the negative 10/7 times y prime. Now, the derivative with respect to x is 7/3. Well, that's just power rule. Bring the 7/3 down. X subtract 1 or 3/3 from 7/3 gives me 4/3. And then over on this side of the equation, derivative with respect to x of 1, derivative of any constant is 0. Okay, so make sure you understand what we're doing here. This is implicit differentiation. And now I have this equation where I can solve for y prime in terms of the other variables x and y. So let's do that. Let's solve for y prime. I'll just simply add this whole expression, add 3/7 y to the negative 10/7 y prime to both sides. Basically move it over to this side. And now to solve for y prime, I'm going to first of all just see I've got a 3/7 here. I want to get y prime by itself. So let's multiply by the reciprocal 7/3, right? What is 7/3 times 3/7? Well, that will just be 1. Of course, over here, 7/3 times 7/3 gives me 49/9. Okay. I'm going to rewrite y to the negative 10/7 as 1 over y to the positive 10/7. So how do I solve for y prime now? I just multiply by y to the 10/7. Multiply both sides by that will give me the following. And so there's my answer. Dy dx is 49/9 x to the 4/3 y to the 10/7. Now again, you could actually solve or find dy dx in terms of x only, because we can indeed solve for y in this original equation. It can be done, but again, this is the way we want to do it with implicit differentiation, and it kind of makes things a little bit easier in solving for the derivative in most cases. Okay, hope this helps.